Hello everyone. Um, I hope you guys are doing good. This is the second lecture in the series of file format. In the first lecture, we have covered about Abru file format, right? Um, and in today's lecture, we will be covering about Apache ORC. Before we talk about ORC, um, I need to cover four things, right? And I have covered these four things in my previous lecture as well. So if you guys want to go through previous lecture before uh, you want to cover this lecture, it will be beneficial for you, and the link is on the right hand side corner. Um, so whenever we want to study any file format, we actually focus on four things. The first thing is read efficiency, right? Read. The second thing is write. The third thing is compression. And the fourth thing is schema evolution. Okay. Okay. And now these are four things on which we're gonna be comparing any file format. And we know that file formats have been divided into two major categories. One is row oriented, right? And the second one is column oriented. Column oriented, right? And we know that, and we have covered this in a lot of detail in the previous lecture. Avro is row-oriented file format, and today we will be covering ORC, which is your column-oriented file format. Okay, so one thing we know, and one thing which I have covered in a lot of detail, that when we talk about row-oriented file format, um, it is highly efficient in writing. Why? Because how row-oriented file format stores the data? It stores one row with all the columns, second row with all the columns, and then third row and all the columns and so on, right? So whenever we want to insert any new row, it knows where to store the data. It has that location, that pointer maintained in somewhere, right? It will take the new row, just put it here, update the pointer to this one. This is a row oriented. In column oriented, how it will do? It will store column one, right? All the column one values together, then column two values together, then column three values together, and then column four and so on. So, and let's say if in each row we have four columns, C1, C2, C3, and C4. So let's say we have one more column here, C4. So what it means that if we want to write a new row, let's say row 5, in which we have four more columns, then it needs to maintain the location of four pointers, one pointer here, one here, one here, and one here. And it needs to write here, 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 and here. It means in very, very simple terms, and even this is nothing technical, that writing in row oriented file formats are highly efficient because we only needs to ingest or insert data at one particular location. In column oriented, writing is not efficient because obviously we need to write data on multiple location, depends on number of columns, right? Now let's talk about reading. Let's say we want to read C2 data, only C2 columns, right? So in row oriented, let's say this is C2, C2 here, C2 here, and C2 here. We need to go for multiple location to read the same data, right? We will read the C2 from here, then here, from here, and from here, right? So what it means that, okay, in row oriented, reading might not be very efficient because we need to seek or disk seek the memory again and again, and it will be a full table scan. But in case of uh, column oriented, we can have the C2 from one particular location, and it will prevent the full table scan, right? So now coming to ORC. ORC is column oriented file format, right? So what it means that reading are highly efficient, right? Reading are highly efficient. Writing is not efficient as much as in column oriented and row oriented, right? When we talk about compression, so as we know, in column oriented, all the column values of the same column are stored together. It means all the integers are stored together, all the strings are stored together. So it means the compression techniques which is suitable to any data format will be applied to any column. So it means column oriented column oriented format are highly efficient, right? Because let's say if we want to if the column C2 is of string type or varchar type or any type, we can apply the compression technique which is more efficient for the string, right? In terms of row oriented, since each row is heterogeneous type of data, heterogeneous type of data types, so it means we cannot bring out a compression technique which is efficient for all the data types, right? For example, column 1 can be integer, column 2 can be string, column 3 can be something. So we cannot have the single compression technique which is efficient for all the things, and that's why in column oriented compression is highly efficient, right? Now when we coming to schema evolution, especially for ORC, schema evolution is partially supported, right? Schema evolution means what? That can we add, delete, update the schema? Schema means the metadata or the header of the file again and again. So yes, schema evolution is supported, but only partially. It means we can add and remove column from the end of the file, right? Let's say we have this file, one column, second column, third column, fourth column. So we can add and remove this particular column, right? So this schema evolution is supported. So this is the overview of row oriented and your column oriented file format. Okay. Now let's come to ORC. So when we come to ORC now, so ORC stands for optimized row columnar. So what ORC stands for? Optimized row columnar, right? So let's jump here. So O is optimized, right? R means row and C means columnar, right? So ORC is column oriented, right? Column oriented file. So what it means? It is highly efficient in reading. Reading is efficient. Writing is not efficient. Writing is not efficient. Compression is highly efficient. And coming to schema evolution is partially supported, right? Now, ORC is the successor of RC file. So RC file stands for row columnar file format, right? RF file. Now, what these people or the actually ORC and RC both are developed by Facebook. So what these people did, they did some optimization on RC file and they created a new file format called ORC. Okay, so this is the theory of ORC. Now let's jump into, before we jump further, I need to cover file structure of ORC in a lot of details. Okay, so when we talk about file structure, um, before file structure, let's see some theory, right? So ORC or optimized row columnar file format provides a highly efficient way to store data. It was designed to overcome the limitation of other file formats. It ideally stores data compact and enable skipping over irrelevant parts without the need of large and manually maintained indices. So this line is very important. The first part is enable skipping irrelevant parts, right? This part. So what it means? So basically, uh, since ORC is column oriented, right? And we know in column oriented, we store column C1 together, then C2 together, then C3 together, right? So the first part is that, okay, if we want to select only C1, we can only select C1. We do not need to go for C2 and C3. So it means this is called pruning, or we can prune the column which we don't want, right? So we can only go for C1 because this is column oriented storage. The second thing is, um, let's say, and let's coming about the indices. So let's say you are reading a book. In book we have 18 chapters. right? And I asked you to read 15 chapter. So what you can do, there are two ways to do it. Let's say 15th chapter is on 322 page number 322. There are two ways to do it. Either you can start from page 1 and read every page and go to 322 page, like scan every page and go to 322 page and then say, okay, this is 15th chapter. Or if we have index somewhere where we have first, second, third chapter, first, second, third, and 15th chapter and the page numbers, right? And let's say here 322 written, 322. So what you can do, that you can read the index, you can go to 15th chapter, take the 322 page and then just read the page directly or chapter directly. So it means if we have that index maintained somewhere, it is highly efficient that, okay, we can skip all the irrelevant data, what we don't want, right? But now the question is how easy it is to maintain indexes. So maintaining indexes, writing to indexes is a very, very, uh, you know, resource intensive job, and to maintain indexes is again a resource intensive job. Why? Because let's say if I insert one page here, if I increase the chapter length for the 14 from, let's say it is till 321, right? And I increased it to 325, then we need to increase this page and a lot of things needs to be done behind the scene. So it's not an easy task. So that is, and the same thing has been written here, that ORC enables us to skipping irrelevant parts, but without the need of large, complex, and manually maintained indexes. And the whole uh, magic of this thing, that okay, why ORC do not need to maintain these indexes, is lies in the structure of the file, structure of the ORC file. Okay, so let's see the ORC file, and it will give you a lot of clarity why ORC is such an efficient file format. Okay. So now when we talk about ORC file format, ORC has been divided into three parts. The file format has been divided into three parts. The first part is header. The second part obviously is data. The third part is footer, right? In header, we have only one text in capital, that is ORC. Okay, I will be covering what is the purpose of header. In data, since we are talking about big data here, right? So what these guys did, what ORC developers did, they said, okay, we will divide the data into 250 MB block, and we will call this 250 MB block stripe. Okay, and we will further divide this 250 MB block into group of rows. Into each group, we will be having 10K rows, 10K rows, and we will be calling each group as row group. So this is 10K, this is 10K. Let's say we have 100K. Okay, so there will be 10 row group, right? And each row group will be have 10K rows, right? So this is your data. Now, into your data, you have two more things. One is your index, the same index what I was giving the example. So before data, we have something called index, and inside this index, what we will have, that we will have metadata about the row groups, metadata about the row groups, that okay, let's say this is row group 1, this is row group 2, this is row group 3. In index, we will have something like, in row group 1, in row group 1, minimum value is 1, maximum value is 50, and the summation of all the values is 100K, let's say. In row group 2, something like this. Okay, and in the striping, in the data itself, we will have, and in this is, I'm talking about each stripe. Okay, so this data is stripe 1, let's say stripe 1. So in stripe, we have data, right? This stripe is of 250 MB. We have index for each stripe, and then we have footer for each stripe. In footer, we have the encoding technique. I will be covering encoding technique, but on the higher level, encoding technique will help you to compress or store the data more efficiently. Now the last part is file footer. So this is file header, this is data. Now the file footer. In file footer, we have two things. The first thing is your metadata, and this second thing is your PostScript. In metadata, you will have your file label, this information minimum. Okay, so in file, what we will have? We will have stripes, right? Sorry, 1 second. So in file, we will have stripes. So what in file, let's say we have 1 million rows. So what it will show you that, okay, minimum value for file is 1, maximum value for this file is for this particular column in some particular, let's say column 1, right? A maximum value is 100K, right? In PostScript, we will be having which compression technique we have used to compress the whole file. It can be Snappy, it can be gzip, it can be bzip, something, right? So on the very high level, what we have a header. Header will contain the text as ORC, right? Then we have data. The data is divided into stripes. Each stripe will have its own metadata. Metadata means its index data, and its stripe footer. Then in each stripe will be 250 MB. The 250 MB data will be further divided into row groups. Each row group will be of 10K rows, right? And then we have footer of the file. In the footer of the file, we have two things. Metadata and the PostScript. PostScript will tell you the file compression technique. Metadata will tell you the metadata about the file, like minimum, maximum value. Okay, I have written it somewhere in more easy way. Okay, so header is ORC. The body will consist of stripe. Each stripe of 250 MB. Stripe will having row groups. Row group will be having 10K each. Then stripe will have set of indexes. Index will have maximum, minimum, and count of each column. Okay, and the data in form of the row groups. And then we have footer. Footer will tell you the encoding. Then in the file footer, we have metadata for the file label, that is maxim and min at the file label of the each column, right? And then we have PostScript, which will tell you the compression technique. Okay, simple. Now, two things. The first thing is, what is encoding? So we know that in ORC, we have stripes. So let's say this is one stripe. This is your index. This is stripe. Let's say stripe 1. Okay, and this is your data, and this is your footer, stripe footer. Data will be further divided into row group, right? Row group will be of 10K. We know this thing. So, and in the footer, we have encoding technique. So what encoding technique means, that you can store data by encoding it. And by encoding it means, let's say the most simple encoding technique is called run length encoding. Like it ORC supports many encoding technique, but the most simple is run length. So let's say, and you do not need to worry about as an end user. ORC will take care of this encoding technique internally by itself. So let's say you have data something like this: A B B B B B C C C. So how many bits it is taking? 1 2 3 4 9 3 12. Since this is a string, then it will be taking 4 bytes each or something like that, right? So in run length encoding, what it's going to be doing? It will say A4, B5, and C3. The same data can be stored like this. This is called run length encoding. So into this case, in footer, it will be saying encoding is equal to run length. So this is one of the encoding. Something is called delta encoding. In delta encoding, what it will do? It won't be storing the full data, rather than it will be storing the delta. For example, let's say some ID. ID will be something like 2, 4, 5, 6, 8, 9, 10, something like this. And the ID is sequential number. So it will be 11, 12, something like this. So what it will do? It will do something like this. It will just store this ID somewhere. Let's say it will store into variable called var1, and inside into the next value, into the next row, it will say +1, then again +1, and here it will show delta or incremental something. Okay, so these are the different encoding technique what ORC supports. So when we talk about ORC encoding techniques, ORC uses type of the reader. Here should be somewhere. Yeah. So yeah, ORC can apply generic compression technique using zlib or Snappy on the top of lightweight compression for even a smaller file. However, uh, storage savings are only part of the gain. ORG supports maximum. Yeah, this one. So ORC uses type space reader and writer that provides lightweight compression techniques such as dictionary encoding, bit packing, delta encoding, run length encoding, right? So we do not need to worry about this. ORC is taken care by himself, by itself, right? Um, but the most important thing is that ORC maintain indexes at 3 levels. The first level is on the stripe label. The second level is on the file footer label, right? Stripe footer, file footer, and then on the row group level. Okay, so let's talk about indexes. Okay, so ORC provides 3 levels of indexes within a file. The file level index is what file level index is stored statistics about the values in each column across the entire file. So let's say we have 2 columns, C1 and C2. Into first column, we have value from 1 till 1 million. In the second column, we have values from 100K till, let's say, 500K. So what file level index will store? It will store C1, 1 minimum, maximum 1 million, C2, 100K minimum, and 500K maximum, right? So now what is the benefit of file label footer? Let's say if I want to select value 500K, it means 500, this one. So will for the C2, right? So what it will do, since this value is nowhere inside my file, it will tell the user, okay, this file won't be satisfying this condition, so you do not need to scan the full file. So this is the benefit of file level indexing. Now the second level of indexing is stripe level. So every stripe, like data is divided into 250 MB stripes, right? And each stripe will be divided into row groups. So statistics on the stripe label indexes is about statistics about the values in each column of each stripe. For example, we have 1 to 1 million in across the file. So let's say in stripe 1, we have column 1 from 100 to, let's say, 100K, something like this. So now let's say if somebody asks us column value of 9999 this. So what it will do? First, it will go to file level index. Okay, this condition is getting satisfied. Now it will send it to which stripe? It will send it to, let's say this is stripe 1. In stripe 1, we have column 1 in which 1 till 100K of column 1 value stored. So it will go to column 1. Now inside each column, we know that we have row groups. Inside row groups, again, we have columns 1 and column 2. And inside row groups also, we have the same minimum maximum value stored. So on a very, very high level, right? We have file, then we have stripes, then we have row groups, right? So let's say we have 1 million rows and somebody asks us 100K row, right? Then file will direct that to stripe, let's say stripe 5. In stripe 5, obviously stripe 5 is 250 MB, and inside stripe 5 we can have multiple row groups. Then it will send, stripe 5 will send it to row group 3, and row group 3 will again send it to that particular row. So this is the overall flow, right? So, and on the row level, statistics about the values in each column set in the 10K rows, right? So now this particular row group 3 will be having 10K rows, and inside this 10K row, that row can be anything, let's say 500th row, right? So this is how the scanning or indexes work in ORC. So what's the benefit of this file indexes at 3 level? Multiple benefits. First, we do not need to maintain a big and large index, which is tough to maintain, which is complex to maintain. We have divided the indexing capabilities across three levels: file, stripe, and row. And that means that none of the indexes are large, right? The second thing is since we have indexing maintained on multiple levels, it means the pruning can be done on the multiple level. It means the full table or full file scanning is prevented at multiple level, right? So the file and stripe level column statistics are in the file footer, right? So that they are easy to access to determine if rest of the file needs to be read at all. The row level indexes indexes include both column statistics for each row group and the position for seeking the start of the row group. Okay, the column statistics always contains the count of the values, whether there are null values present. Most other primitive type include minimum and maximum values for, and for non for numeric types the sum as well. Okay, and now let's see the example how indexes looks like. So let's say this particular column is integer. So for integer, we have two things, minimum and maximum, right? For string, we have again minimum and maximum in some dictionary encoded form, right? So this particular um, uh, index is on row level indexes. So this is only for 1,000 rows or 10,000 rows. This is 10K, right? This is row group 1, for example. This is row group 2. For row group 2, we have again the same indexes maintained. Okay. So yeah, so again, let's see this diagram as well. So for each stripe, which is of 250 MB of data, we have raw data, which is divided into row groups, right? And then we have index data for each stripe. Then we have stripe footer, which will tell you the encoding, right? Then this encoding will be of, can be of run length, dictionary encoding, delta encoding, different kind of stuff. Then we have header of the file and footer of the file. um, Header of the file will contain only ORC. The footer of the file will contain two things, the column level information and stripe level information, correct? So this is all about indexing, and this is why it is clearly written here that ORC will enable skipping over irrelevant data without maintaining large and complex indexes. Okay. Uh, okay. One more important thing about predicate pushdown, right? Predicate pushdown means what? That okay, we need to predicate means anything which is written into the where clause. So we have select star from table 1 where id is equal to 5. So this is called predicate. Okay, id is equal to 5 is called predicate. Now how predicate work, right? How predicate work, that okay, this query will be compiled, it will go to the storage. Now storage can be of anything. Let's say it is into the row oriented file format. Then it will see where id is equal to 5 is stored. Then it will seek it, full table scan, maybe something. Then it will return into it, right? Now predicate pushdown means what? Like without predicate pushdown, we need to scan the full table, and on the full table result, then we need to apply filter. Like we need to fetch the result first, fetch without predicate pushdown, fetch the result, and then apply this filter. Now predicate pushdown means, can we do something that this particular predicate or this particular condition can be pushed down to the storage and we only get the result which is relevant to us? What is the benefit? That less data will flow through the network. So what ORC says, and since ORC has indexes maintained on different levels, so predicate pushdown is easily supported, right? One more thing about ORC. ORC has been developed by Facebook, right? And Hive is also been developed by Facebook. So ORC is fully compatible with Hive, support even complex data types. Now, when we talk about schema evolution, and I have covered schema evolution techniques in my previous lecture. So schema evolution has been maintained through protocol buffer. Okay. So I think we have covered. Now, when we talk about again predicate pushdown, ORC store indexes with minimum and maximum, we have covered it. Read filters out section of the file, entire file, stripe and row group. So this is because of 3 level of indexes, and then engine needs to apply row level filter, right? Now, what are the benefits of ORC? Efficient compression because of multiple things. It will do the compression and then it can also do encoding, right? Faster reads are supported because obviously we do not need to read the irrelevant columns, and ORC has been proven on large scale deployment. Facebook uses ORC file for more than 300 petabyte of deployment. Okay, now let's see one more thing and then we will jump to practical. Um, so let's say we have one file of text format. The size of the file is 585 gigs. If we store that file using RC file format, it can be stored as it can be compressed to 505 gigs. If we store using Parquet, it can be compressed to 221 gigs. But if we compress the same file, that is 585 gig file using ORC, it can be compressed to 131 gigs. That is 78% smaller than the text file, right? The larger block sizes, column format arranges columns adjacent between file for the compression and the faster access. And this is the benefit of ORC, that columnar format arranges column adjacent within file for compression, fast access, right? So this is everything you know about ORC. Um, Let me see if I missed something. Um, One more important thing. And ORC, see what we have explained so far, that in the file structure of ORC, we see that there are header, footer, and everything. So ORC files are completely self-describing, and that means that ORC file format do not depend on Hive metastore or any other external metadata. The file includes all the types and encoding information for the object stored in the file. Because the file is self-contained, it does not depend on user environment to correctly interpret the file content. And we have covered it when we are talking about the file structure, right? So this is okay. So this is all about the theory. Now let's jump to the practical. So as I was explaining you guys that okay, ORC and Hive are fully compatible. So let's start with Hive. Um, Before we jump to the practical, let me cover one more thing. So let's say whenever we want to write data into ORC file format, there is something called SERDE. SERDE. SERDE is nothing related to ORC, but it is a generic concept. SERDE means serialization and deserialization. For any specific specialized file format, we need to tell the system how to serialize the file. It means how to store the file into its file system, right? Serialization means how to store the file inside the file system, and then deserialization means how to read the file from file system and send it to the user through the network. Obviously there's a network in between, right? So in ORC we have ORC SERDE, in Parquet we have Parquet SERDE, in text we have text SERDE, right? So whenever we talk about ORC, we need to tell the system that okay guys, or Hive or Spark, please use ORC SERDE, right? And it's very simple to tell it to system. I'll explain it to you. But one thing which I need to explain, in Hive you cannot use direct what I can say, let's say if you have one table which is using ORC SERDE, then you how to insert data into ORC table. So to insert the data into ORC table, first step is to create a non-ORC table. Non-ORC table means that okay, which is not ORC SERDE, right? Which is not using ORC SERDE. Now insert data into it, insert data into this table, like insert data, and then third step is create ORC table, right, using ORC SERDE. And the fourth step is from, let's say this is table 1, this is table 2. From table 1, insert data into table 2. This is in Hive, right? So let's see how it works. So what it means that uh, we cannot directly load data into ORC. we need to follow these steps. So let's see quickly. So I have my Cloudera VM up here. So what I can show you here, 1 second. And here is my Hive, right? This is my Hive shell. So if I say show tables quickly, show tables, what I can say that I have created one ORC table here, but I will drop it. Drop table, orders underscore ORC. So I'm dropping it. Okay, so this is done now. And I have one table called orders. Okay, so let's see. First of all, select star from orders. Orders limit 5. Let's say I just need to say 5 rows just to show you guys, right? So in orders, we have order ID, date, order status, and different kind of stuff. So let's see how order table looks like. Describe, formatted, and let's say orders, right? What we can see here, that order has 4 columns, which we know, that order ID, order date, order customer ID, and order status. We know this thing. One most important thing which I need to show you here is Serde library. So what we can see here, that inside this Serde library is text input format, and like it is by default, the data has been stored into text input format. So into our case, orders can be, this is table 1 is orders, right? And inside this, we already have the data. Now we need to create a new table for the ORC. So let's say we are creating a new table from the same, like with the same structure. One thing, how we need to this is the describe statement, right? But if we need to see how we need to create this table, right, then we can say show create table orders. So this will show the create statement. Okay, so now we just need to think about this thing and just copy this part, take it here somewhere. We'll go ORC and we'll go here. So I just pasted it here again. I did it first. And so now this is your table 1, right? Into this case, this is my table 1, which is like text format table, table 1. Now, if I want to create a new table, which will store the data as ORC, we just need to say stored as ORC. Simple. We just insert stored at ORC at the end. Okay. So let's copy this command quickly. I have just appended stored at ORC. It means just use ORC Serde to store the data now. Okay. So this is done now. So table is created. Now when I say describe formatted ORC now. So what it will say that, okay, it is now using ORC Serde. Output and input format is ORC input format, ORC output format, right? So this is good now. One more thing, let's say one more thing is, let's say I want to describe formatted this again. This is storing data in user Hive warehouse. Now let's see the size of this data. So when we go here and see this one, so it will show us the text file format data. This is around 299 MB, right? Or something like 299 something. So now what we will do, we will be storing this data in ORC format, right? So how to do it? We will be saying like insert into which table? Orders underscore ORC. From which table we need to select? From orders, right? Select star from orders, correct? And then we will run it, insert into this, and we will hit enter. Now obviously it will invoke some MapReduce job, it will do a number of things, and it will take around 1 or 2 minutes, right? In the meantime, this is your Hive and ORC integration. Let's jump to Spark integration. Okay, so in Spark, what I'm showing you that I have one file at this path. I'll show you now. So what I'm doing, let me explain here. So into Spark, what I'm doing. So I have one file called zipcode.json. Okay, so I'm writing my Spark code. I will be storing this zip code. I will be reading it first, right? And then I will be writing it into ORC format. Okay, so let's read it first. Let's see where this file is. So this file is in here into test data. So what I can say that, okay, I have one file and the C user Rajput test data, and then we have one file called zipcode.json, right? So when I go here into my code, so this is the location. So what I'll do, I'll show you now in 2 minutes. So what I'm doing here on a very high level, I am creating one Spark session, simple, right? And using that Spark session, I'm reading one file. The file is in JSON format, okay? And then I'm loading that file into a data frame called zip. Then I'm showing that zip here. And at the end, what I'm doing, I will be storing that into ORC format, inside which location, let's say I will create zip ORC, some folder called zip ORC, okay? And let's save this and let's run this. So first of all, let me show you here. We don't have, in fact, let's do one thing. Let's remove these all. So now what I can say that we have only our source file here, right? So now let's run this. So what it will be do? It will be doing, it will read this file, zip code JSON, and then it will write that file to a new folder called zip code ORC. So what we have seen here, that zip code ORC folder had been created, and we have a new file called zip code, whatever this file is, right? Snappy.orc. Okay. And the size of the file is 41 KB. Size of the raw file was 11 MB. So it, from 11 MB file, it reduced to 41 KB file, right? So this is your Spark. Now let's jump back to your Hive. So what we can see that it took around 26 seconds to load the data. Now let's do one thing. Let's see here as well. So my file was of 299 MB or something. Then I'm doing here. It has been reduced to 16 MB, right? So this is done. Now, one more important thing which I need to show, how to read the data, right? So first thing, we can read it from Hive. Select. We do not need to worry about, like as a user, we do not need to worry about how data is stored behind the scene. For us, everything is same, and we'll say limit 10, right? So what, sorry, select star from orders. Okay, so now this is the one way. Let's say we do not want to jump to Hive, we need to see from normal shell. So there is a utility provided by Hive to us. That utility is called ORC file dump. ORC file dump, right? So what we can say, if we want to see the file metadata, we can say ORC file dump, then Hive ORC file dump, and then user Hive, whatever the location of the ORC file. So into my case, the location was this one, right? This one, and I have written it. So what it will do, it will read the metadata, see what it is trying to do, structure of this file it is trying to find, and it will give us in 2 minutes. Okay. So this is all about ORC, what I can say. So it will show us everything what we have learned so far in theory, right? So what it is saying that, okay, rows in the files are 68,883. It is using zlib compression is in the file footer, right? Then it is the structure of the files is this. It has 4 columns, and it is renamed them call 0, call 1, call 2, and call 3. Then it has only one stripe. Stripe 1, in stripe 1, column 0 has 68,000 this value, and has null. No, null is not there, right? Column 1 has minimum value is 1, maximum value is 683, sum is this. And it is the same thing what I was showing you. On the file label, it is, since we have only one stripes, right? So what it, one stripe here. So it is showing the same thing, that minimum is 1, maximum is this. The same thing, and it has done some optimization for itself, but then it is showing here that, okay, which encoding technique it has been used, like dictionary encoding or direct encoding, and then it has been doing for the padding ratio 0, different kind of stuff, right? So this is all about ORC. Now let's say if you want to see the data, we can simply say ORC dump -d here. It will show you the data. Okay, one thing before we end this lecture is, if you want to study more, then there is ORC. Obviously, ORC is Apache project now. So everything about ORC has been written into very good documentation. Is ORG Apache orc.apache.org, docs and everything, like whatever I'm telling you guys, right? So when you go to Hive DDL, see, stored at ORC, and then the same commands what I'm using, ORC dump file to see the metadata, ORCD to see the data, right? See, the data is coming now, right? Um, so this is all about ORC integration with Spark and Hive. To know more, obviously, please, I'll request you guys to go through it. It will show you everything, Spark DDL and everything. See how to use in Spark using ORC, and how to see metadata. There's something called ORC tools meta, and then file of the file ORC tools data to see the data. So next lecture will be about Parquet, but please go through it. Please like, subscribe, and share this video. And thanks again for the time, guys. Really appreciate it.